last lecture we studied about solar system, and now in this lecture we are going to understand theories of origin of the earth. So there are about 6 theories. We are going to discuss each and every theory in a very great detail. And apart from these theories, we are also going to understand formation of stars and as well as formation of planets. So this topic, it is very important from both your prelims and as well as your mains. So let's get started. Let us see the first theory. So as I said earlier, there are 6 important theories that you need to remember. So first theory is Kant theory. So here, what is this Kant theory? So first theory is Immanuel Kant's gaseous hypothesis. So name itself, it is saying like it is regarding to gases. So according to Kant, he mainly says that there is existing of primordial matter. So this primordial matter means which is already existing, okay, which is already existing in our space, okay. Whenever during this formation of this solar system and as well as we can say during the formation of earth and everything, so already there is some matter which is existing in space. So that is called as primordial matter. So already this primordial matter which is present, but this primordial matter which is not concentrated in one place. But these primordial matter which is mainly scattered in our universe, okay. So in our universe, this primordial matter which is mainly scattering, and this primordial matter which is containing one important feature is it is a slowly rotating. So whenever this primordial matter which is slowly rotating here, it mainly forms a cloud. So this cloud of gas, it is called as nebula. So he mainly says that first there is primordial matter, and this primordial matter is not concentrated in one place, it is mainly scattered in our universe. And this primordial matter which is having one characteristic, so that characteristic is it is mainly moving very slowly. And during this movement of this primordial matter slowly, it is forming a cloud. So it is called as a cloud of gas. The name for this cloud of gas is nebula. Okay, so we have nebula. So in this primordial matter, we will be having particles. These particles, whenever the cloud, whenever this nebula it is rotating, so these particles, they will collide with each other. So whenever these particles are colliding with each other, why? Because of gravitational force. So because of gravitational force, whenever this nebula which is moving, so these particles, they will collide with each other. So whenever there is these particles are colliding with each other, so whenever one particle is colliding with each other means it will generate heat, right? So because of colliding with each other, that is generating heat. So because of generating heat, temperature of this matter, it is increasing. So whenever temperature is increasing, then whatever the solid particles are present, they will be converted into gaseous particle. So what is the important property of gas? That will expand, right? So because of this solid particles which are converting into gaseous particle, because of rising of temperature, then what happened there is because of continuous increase in temperature because of collisions, and there is rising of rotation, okay, there is rising of rotatory motion of this nebula. So because of this, then what happened? So nebula which mainly started spreading. So initially nebula it is in this size, it is started spreading. So nebula started expanding of its size. So after expanding of its size, then what happens? Size will be increasing, obviously. Size of this gaseous cloud which is increasing continuously, and there is increasing of rotation speed of particles. So what happened whenever anything which is rotating means, so here we need to apply physics. So we need to bring back whatever the physics we studied in our plus 2 or in 10th class. So here you need to recall 2 important forces. First one is centripetal force. Next one is centrifugal force. Centripetal means, so this body which is attracted towards center, that is called as centripetal force. And whenever centripetal force is acting on any body, then this body will also have centrifugal force. It will try to move away. So these two forces that will be present in this nebula. Already we know that this nebula will be containing number of particles. So these particles, they are having centripetal force and as well as centrifugal force. Centripetal force mainly want to bring these particles towards center, and these particles, they want to move away. So in this two forces, centrifugal force which is greater than this centripetal force. So because of this nebula will be expanding. So what is the reason behind expanding of this nebula? That is centrifugal force. Centrifugal force, it is more than compared to that of this centripetal force. So because of this expanding of this nebula that is seen. So because of this expansion here, and as we know, because of this forces that will leads to formation of this rings. For example, size of nebula is like this, and there is increasing of size to like this, and there is increasing of size. So because of this, that will lead to formation of concentric circles or concentric rings mainly formed. And whenever these concentric circles are forming, then that will also leads to formation of mass. So residual mass will be created. So here first we will see formation of sun, right? So formation of sun will be happens in middle, and we can see in this corresponding rings also there will be accumulation of mass that is happened, and finally that will lead to formation of our planets. So this is our first theory, that is Immanuel Kant gaseous hypothesis. So let us have a brief recall. First, there is primordial matter, and this primordial matter which is scattered in our universe, and this matter will be having one important feature, that is slowly rotating of this mass, and that will lead to formation of cloud of gas that is called as nebula. And these nebula will contain small particles. Whenever this nebula which is rotating, then what happen, particles, they will collide each other. So whenever they are colliding, that will lead to release of heat, or heat is generated. So because of this heat generated, that will lead to increasing of temperature of that primordial matter. So this solid matter will be converted into gaseous matter due to increasing of heat or temperature. So later on, after becoming gaseous matter, it will expands. So because of expansion, even rotation or rotationary movement or rotationary motion will also increasing rate. So what happened, because of increasing the speed of rotation, and there is increasing of collisions, and there is increasing of temperature. So because of this, centripetal force and as well as centrifugal force which is more compared to that of this centripetal force, that will lead to formation of concentric rings. And we can say formation of central residual mass. So this central residual mass, it is considered as our sun. And we can see irregular rings are formed. So in these irregular rings also there will be development of cores or formation of corresponding planets will be happen. So this is our first theory, that is Immanuel Kant's gaseous hypothesis. I hope it is very clear now. Now let us try to see image of this theory. So we are having this primordial matter here. So this is our primordial matter, and this matter will be rotating. So because of this rotation, so here we can see formation of a cloud. This is called as cloud of gas. This is our nebula. So in this nebula, particles, they will collide with each other, and that will leads to releasing of heat, generation of heat. Because of this heat, there is increase in temperature. So because of increase in temperature, there is spreading of this gaseous nebula. Because of this increasing of heat and spreading of this nebula, there is also increasing of rotation of this nebula. So because of this, centrifugal force which is greater than the centripetal force, there is expanding of this nebula is seen. And here in center we can say residual mass is formed, that is our sun. So around this residual mass there will be concentric circles which mainly formed. So in these concentric circles also, here mass, they will be accumulated. So finally that will leads to formation of our planets. So in this way our solar system formed. This is our Kant gaseous hypothesis theory. So if you see this image, you can easily understand and you can draw this image if at all any question appears regarding this Kant's hypothesis in your mains. Now let us try to see second theory. It is our nebular hypothesis of Laplace. So regarding this Laplace, I think there was one question which appeared in prelims. So if we are talking about this Laplace theory, it is nothing but some modification of our Kant's theory. So Laplace theory, it is nothing but modification of our Immanuel Kant's theory. So he mainly assumed that there was a huge and hot gaseous nebula. Nebula is nothing but cloud which mainly contains dust, gas, etc. in the space. So in the space already there is one nebula. So this nebula contains dust, gaseous particles, etc. And this nebula, which is mainly rotating on its axis, which is mainly not present. Okay, so here Kant said that so there was only primordial matter that is present, but here Laplace says that already there was nebula in our universe, and this nebula which is rotating on its axis from very beginning itself there was nebula. So this is a thing which mainly not said by Kant. Kant started his theory with primordial matter. Here Laplace starts his theory with already nebula which is existing in our universe very beginning. In very beginning itself nebula it is present. So this is the starting theory of this. This is how Laplace starts his theory. His theory mainly says that a huge and hot gaseous nebula in the space which was rotating on its axis from a very beginning. And what happened? Because of this rotating of this nebula on its own axis, after some years, after some time, so there is cooling of nebula which mainly happen. So whenever cooling means it is losing heat, right? So losing of heat occurs from outside. For example, let us take like any dish. For example, let us take idli. So idli. So your mom prepared idli and she kept idli on plate and she gave you. So after some times you can see idli, if you touch idli on surface it will be cool, and if you cut the idli, then inside you will feel some hotness or warmness. That means whenever any cooling is happening, first of all outer surface will be cooled down. Outer surface will lose the heat but not inner thing. So in this way, whenever cooling of objects means we have to consider first outer surface will be cool and later on cooling will be happens from outer surface towards inwards. So in the same way this nebula also started cooling, means outer surface it will lose heat, right? So after losing of heat from outer surface, what happened whenever any subject is hot means we can see there will be occupying much volume or much space, and whenever it is cooling means then the size will be reduced. For example, let us take example of jam. Whenever you are preparing jam, whenever it is extremely hot means it will occupy much space. For example, if you are pouring jam in any plate means it will be like spreading large amount of area. So if you take same jam after cooling means if you take 1 spoon means it will be like only that spoon. That means we can say whenever any body which is cooling means that will reduce in size because of contraction. Okay, so because of contraction we can see size will be decreased. So this is a thing which mainly said by Laplace. So Laplace says that this continuously rotating nebula which starts cooling down. So during this cooling down outer surface will lose heat, and because of losing of heat, so because of this that will lead to decreasing of size. There is a contraction of contraction of that matter which has happened because of cooling. So to sum up, here Laplace mainly says that planets are formed from nothing but rapidly spinning nebula. So this nebula, whenever it is condensed and whenever it is cooled and becomes solidified into celestial bodies such as stars, planets. So this is nothing but our Laplace nebular hypothesis. So what he says nothing but what Kant says, but he said that already this nebula which is existing from very beginning. So after this nebula which is mainly cooling down, so because of cooling that will lead to contraction, solidification. So because of this that will form celestial bodies, for example planets, stars, etc. So now let us try to see image, and this flowchart will be very useful whenever you are writing your mains answer. So first one here, this is our nebula, right? So here this nebula which is mainly rotating on its axis. So whenever this nebula which is of irregular shape which is rotating means it will mainly forms disc-like shape. So after this rotating of this disc-like shape, what happened? Matter, okay, heavier matter will comes into middle, right? So because of this what happens? Central mass which mainly forms. So this central mass is nothing but our protosun. Okay, central forces, they balances gravitational forces, and later on the ring which mainly forms. So in these rings what happen? Mass will be accumulating, condensing, solidifying, that will forms into our planets. So this is the thing which mainly said by our Laplace. And now let us move on to next theory. Next theory, it is planetesimal theory. So you need to understand what is the meaning of planetesimals. So planetesimals means, in simple words I can say, these are very small. These are very small celestial bodies which are present. Okay, which are present when our universe formation it is at early stage. So during the formation of our universe at early stage, what of the small celestial bodies are present? They are called as planetesimals. So this is planetesimal theory of Chamberlain and Moulton. So now let us try to understand what is this Chamberlain and Moulton said. So they said that there is one body. So this body, it is our proto-sun. So proto-sun is present. So whenever any star, okay, whenever any star, or we can say like giant intruding star which mainly comes through this way, so because of attraction or gravitational force, so this star will have capability to extract some part from this proto-sun. So because of this, okay, because of this, whenever it is bringing some small part from this proto-sun, after cooling down, that will lead to formation of planets. So this is nothing but this planetesimal theory of Chamberlain and Moulton. So according to this theory, so these people mainly says that, so when intruding star which comes very close to our proto-sun, okay, infinite number of small particles, they will be detached from our proto-sun. Okay, mainly because of gravitational force. Due to gravitational force, so here this intruding star that will have capability to detach some part of this proto-sun, and this matter, that is nothing but dust, gases, rock fragments, and that eventually come together and they will unite together and they will form our celestial bodies like planets, sun, stars, etc. So and these particles, they will start revolve around our proto-sun. Okay, so this is about this planetesimal theory. To understand this, let us see this image, then you can easily understand this theory. So here this is our proto-sun. Let us take this example. So whenever any rogue star or intruding star which is very much passing very much close to our sun, so because of this gravitational force, it will pull off or detach some amount or some part of this sun along with it, right? So after cooling of these particles, okay, after cooling down of these particles, they form small celestial bodies. They are called as planetesimals, and these planetesimals, they unite and they form our planets. So this is about our planetesimal theory. I hope it is clear. And now let us move on to tidal hypothesis of Jean and Jeffrey. So this is our fourth theory, that is tidal hypothesis. So this tidal hypothesis, which is very much similar to that of this planetesimal theory of Chamberlain, but there is a very small difference. So here these persons like Jean and Jeffrey, they supported this theory of Chamberlain and Moulton, that is our planetesimal theory. So these people mainly says that this proto-sun to be hot burning mass of gas. So this is hot burning mass of gas. But if you go back to this planetesimal theory, so these Chamberlain mainly considered this proto-sun to be cool and as well as solid and rocky. So here Chamberlain theory considered this proto-sun to be cold, solid and rocky. But here this tidal hypothesis of Jean and Jeffrey mainly considered this proto-sun to be hot burning mass of gas. And next one is, due to massive gravitational force of intruding star, a huge amount of mass will be ejected from this primitive sun, which later becoming building material for our future planets. So this is a thing which mainly said by our planetesimal theory, but only one difference is, so this Jean and Jeffrey theory proposes this proto-sun to be hot burning mass of gas. But Chamberlain theory said that this proto-sun to be cooled, solid and as well as rocky. So this is the some difference that is mainly seen between this tidal hypothesis and as well as planetesimal theory. So this is about this fourth theory. And now let us move on to next theory, that is our revised nebular hypothesis of Otto Schmidt and Carl Weizsäcker. So it is about revised nebular hypothesis theory. So now let us try to understand what this theory says. So according to this theory, it mainly says that here sun is present, and sun which is surrounded by solar nebula. And this nebula mostly contains gases like hydrogen and helium. And even in this nebula, it also contains some particles of dust. Because of friction and as well as collision of particles in this nebula, that will lead to accretion, that means uniting of these particles. And later on, disc-shaped cloud and planets, they were formed. Okay, so this is fifth theory, that is revised nebular theory. So in this revised nebular theory, it mainly says that, so there is solar nebula which is present here. Solar nebula, that means cloud of gas, and already this gas which is present around sun. Already sun is there. So around this sun, this solar nebula, it is present, and this nebula mainly contains hydrogen and helium along with some dust particles. So what happened, because of friction and as well as collision of these particles, that will lead to uniting of two or more compounds, and that led to formation of our planets. So this is about this revised nebular hypothesis. I hope it is clear. And next theory, it is the Big Bang theory, and it is the most accepted theory. So what is this Big Bang theory? To understand this Big Bang theory, I will say one simple example, and this example, it is not my own, it is given in your NCERT 11th class book. So to understand this theory, it mainly says that first you have to take a balloon, that is inflated balloon, and on this inflated balloon you have to keep some dots by using some color pen, and now you have to fill this balloon with air. So earlier, before filling of air, you see those particles which are very much, those dots that you pointed are very much near. But if you are filling that balloon with air, and if you are increasing the size, the distance between these particles is also very much high. So in the same way, this is nothing but our Big Bang theory. So if you are talking about this Big Bang theory, it said that initially all matter constituting the universe existed in a form of singular atom. So earlier, okay, so this Big Bang theory mainly proposes that, so in our universe, it is mainly existed in the form of singular atom. For example, it is like a tiny ball. Okay, so this singular atom is called as like a tiny ball. So what happened? So this tiny ball will contains very less volume or very small volume, and it is having infinite temperature, and as well as it is having infinite density. So it is having infinite density, infinite temperature, and as well as having a very small volume. Then what happens? Suddenly explosion of this ball happened. So this explosion which happened nearly 13.7 billion years ago. So when this explosion happened nearly 13.7 billion years ago. So this tiny ball, so this singular atom which exploded violently. So because of this, that result in huge expansion of this singular atom, right? So the expansion occurred rapidly within fraction of seconds. So there is expansion. So for example, let us take any bomb. Okay, so if you are firing any bomb means, so whenever bomb has been blasted means it will the particles of that bomb will be spread here and there, right? So in the same way you can imagine this Big Bang theory like a bomb. So the expansion occurred rapidly within a fraction of seconds. After this Big Bang happened, later on what happened? Slowing down, or we can say slow down is happened, and the expansion which is mainly continuous present day. After explosion, what happened? Those particles, they started cooling down, and till now also there is expansion of this is happening even today. So as a result of this expansion, some energy which mainly continued to convert it into matter. Some energy was converted into matter, and the first atom which began to form within first 3 seconds of this Big Bang event. So first atom when it formed within first 3 minutes of this Big Bang event. So after the first 3 minutes, so we saw formation of these protons, neutrons, okay, and these protons and neutrons, they assembled and they formed hydrogen and as well as helium nuclei. So because of this, we can see there is abundance of helium. Helium, it is a key prediction of Big Bang theory, and this helium also confirmed by scientific observations as well. So because of this is the most trusted theory of formation of our Earth and as well as our universe. So within 3 lakh years from this Big Bang, temperature that came down to 4500 Kelvin. So now you can understand how much hot it was. And with the passage of time, matter cooled and more diverse kind of particles that began to form from this basic atoms like hydrogen and as well as helium. And that eventually condensed into stars, galaxies in our present universe. So this is Big Bang theory. So what is this Big Bang theory? Let us have a small recap. So according to this Big Bang theory, it mainly says that universe which mainly existed from a singular atom. So this singular atom which mainly like a tiny ball which is having small volume, infinite temperature and as well as infinite density. 13.7 billion years ago, this ball exploded violently. So because of this, that led to huge expansion. So expansion which mainly occurred very rapidly within fractions of seconds. So after this Big Bang, that led to cooling down and slow down, and even now we are seeing that is expansion that is happening in our universe. So because of this expansion, so some energy it is released, right? So this energy which is converted into matter. So first atom which mainly began in this Big Bang event within first 3 minutes here is protons, neutrons, etc., and they united to form atoms like hydrogen as well as helium. So because of this, there is abundance of helium. Helium, it is one of the key prediction of Big Bang theory, and it also scientifically proved. And later on, within 3 lakh years of this Big Bang, temperature came down to 4500 Kelvin. And after passage of time, here matter cooled down and more diverse kinds of particles that began to form, and later on that led to formation of our today's planets, stars, galaxies, etc. So this is about our Big Bang theory. And if you see this image, then you can understand. Here we have this nebula. So what happened? Big Bang happened and that led to expansion, and till even today there is expansion of this universe which is happening. Okay, so this is about this our Big Bang theory. And now let us try to talk about formation of stars, and this is very important, and actually I took this topic from our NCERT 11th class. So we are talking about formation of the star. So the formation of the stars is believed to take place nearly 5 to 6 billion years ago. So when these stars have been formed, it is believed to have formed nearly 5 to 6 billion years ago. So the matter and energy, they were distributed unevenly in the early universe. So in early universe, already we know that matter which is not concentrated in one place, it is mainly distributed unevenly in our universe. So whenever the matter which is distributed unevenly here, so density of particles will be very much different, right? So based on their composition and based on their gases, etc., there will be different density. So due to this difference in density, that will give rise to difference in gravitational force. So whenever density is high, means gravitational force will be high, right? So because of differences in density, that mainly gives rise to differences in gravitational forces. So because of these differences in gravitational forces, then matter got drawn together. So whenever this body which is having higher gravitational force than compared to this body, means it will try to attract it, right? So whenever it try to attracting, whenever it will come together, means they two combines. As a result, matter will got drawn together. That led to formation of this galaxies. So you will be having one question like, so what is this galaxies first of all? Galaxies nothing but, so it mainly contains large number of stars. Galaxies nothing but, they are containing large number of stars. We belongs to Milky Way galaxy. Our solar system belongs to Milky Way galaxy. So the formation of a galaxy, which mainly starts with accumulation of hydrogen gas. Okay, hydrogen in the form of a very large called as nebula. So when we are having this nebula, okay, let us come back and let us see how these galaxies are formed. So there is a nebula. So in this nebula, what will contain? It contain gas and as well as dust. For example, there is hydrogen gas that is present, for example. So this nebula will be growing in size. So because of growing nebula, then that will lead to collisions, and because of collisions, that will lead to formation of clumps of gases. So these gases clumps that will grow into size, right? So denser gaseous bodies, then these clumps, they will form together and they will form into big bodies, and these big bodies that will give rise to formation of stars. So here these stars are mainly formed from nebula, and this nebula mainly contains hydrogen gas. Okay, accumulation of hydrogen gas in the form of a very large cloud called as nebula, and in this nebula, which mainly contains particles, and these particles, they will collide each other, they will form localized clump of gases, and these clumps mainly grow into size. But how these clumps grow into size? By uniting one clump with another clump. So finally that will lead to formation of our stars. And now let us try to talk about formation of planets. So planets, they are formed, okay, planets, they were formed nearly 4.6 billion years before the present. So they formed 4.6 billion years ago. So localized clump of gases within this nebula, they started forming a core to gas cloud, and due to gravitational force, there is a huge rotating disk of gas and dust developed around the gas core. So how these planets will be formed means, again we need to take this nebula. So in this nebula, which mainly contains gas, so it is also called as cloud of this gas. So due to gravitational force, whenever it is rotating, so it will form like a huge disk of gas, right? So and whatever the dust which is developed around this gas core, so whatever the dust which is present, that will start condensating. So condensation starts within this gas cloud, and the matter around the core, which mainly developed into small round objects. So now let us come to first. So there is nebula. So this nebula which is rotating around. So this nebula nothing but gas, cloud of gas. So whenever this nebula which is rotating here, then that will converts into disk shape. So whatever the dust which is present around this or in this nebula or this disk shape, so that will condensation. So the condensation will be started in this gas cloud. So after this condensation, what happened? The matter which is mainly developed around this or whatever the matter which is present in this disc shape, that will forms into a round objects. So these round objects, they are called as planetesimals. So planetesimals are nothing but these are the small celestial bodies that are present during early stages of formation of our universe. And what happened? So these planetesimals, so these are the small celestial bodies, they will come together and they will combine with each other because of gravitational force. So they will ultimately form towards larger bodies, and these larger bodies, what happened? They will revolve around our sun. So in this way here, the number of small planetesimals, they collide with each other and they unite with each other and they will form into larger bodies. These are called as our planets. Okay, how these planets are formed? So these planets, they formed 4.6 billion years before or ago. So there is a nebula. So in this nebula, we are having gas particles and dust particles. So this nebula which is rotating, and after rotating it will forms into a disk of gas, and the dust which is developed around this gas core, that will forms into condensation. So after this condensation, that will lead to formation of small celestial bodies are called planetesimals. So these planetesimals, they will unite with each other due to this gravitational force and they will form larger body. So these larger bodies are nothing but today's planets. So in this way, formation of planets that happened. Okay, so this is about formation of planets, and we discussed formation of stars. Formation of stars, here there will be no planetesimals or accumulation or joining of planetesimal, but it is mainly formed from this hydrogen containing nebula. Okay, so this is about different theories related to formation of our universe, and as well as we studied about formation of stars and also formation of planets. So this is one important topic. If you understand this, then we can move forward. So if you don't understand this, please watch this video at least twice to understand the concept. And I went very slow to make you understand this concept. So by this I am concluding today. Thank you so much.